Hey everyone, today we're diving into a really cool tool on Azure that helps you test the resilience of your applications called Azure Chaos Studio. If you're building your cloud applications and want to ensure they can handle unexpected failures, this video is probably for you. Azure Chaos Studio is a managed service that basically allows you to run chaos engineering experiments directly on your Azure resources. It's designed to simulate real world outages and disruptions, the likes of Azure VM reboots, network latency, or even zonal failures within inside your region, so that you can identify those weaknesses in your system before they cause major issues in production. Now you're probably wondering, why should I care about this? Simple. High availability and reliability is what we're looking for here. So by injecting faults in your systems, you get to observe how those applications react. Do your applications fail gracefully? For example, do your resources trigger alerts properly when they go down? That's where Chaos Studio comes in and helps answer those questions without waiting for a real world incident. So as you can see here, I've currently got three VMs, and you'll see the availability zone in 1, 2, 3. So basically split across multiple availability zones with inside my Western Europe region, basically meaning if one region goes down, I've still got the other two VMs, or one zone goes down, I've still got my other two VMs with inside that region. I've also got a load balancer as well connected up to those. So for anyone who's not aware, the purpose of a load balancer is basically to distribute incoming traffic across those VMs that I've just shown you to ensure high availability and reliability. So in here, you'll see in my backend pools, I've got my three VMs in here, and then the zones connected to those. So the goal here is to basically upset one of these VMs, i.e. power it off, and hopefully will still remain online with the other two virtual machines. To do this, we're going to use Azure Chaos Studio. Chaos Studio is an area where you can run certain real world scenarios with inside your environment. To do this, now we got to start with targets. So we go into our targets at the moment, and you will see basically all of my resources in here. But if we filter based on the resource group that I'm running in, you will see all of the resources inside that resource group. And what I'm currently focused on is these three VMs. Now, targets are the resources in Azure that you want to essentially disrupt. So there could be virtual machines, AKS clusters, other workloads essentially. I think of targets as the actual infrastructure or services that the chaos will be applied to. So to do this, you need to basically enable these three machines. I've currently got it done as well, and you'll go up there and enable those as direct targets. Once you've done that, you go into your experiments. So experiments, on the other hand, are the blueprints, or I tend to think of them as orchestrations of the chaos events that you want to run. So they define what faults is going to be injected into those workloads, when to inject them, and basically how to inject them using steps and branches. I've currently got one in here at the moment, so we're going to go in and look at that in greater detail. And you will see here there's an edit button. So here is basically the orchestration, how I want to run this. So you'll see here we've currently got steps and we've got branches. So a step is a single action, like shutting down a VM or introducing a network delay. A branch is a sequence of steps that can be run in parallel. So this allows you to model complex scenarios like causing failures across multiple services at the same time, i.e. like an application, and usually there's a SQL database connected to that application. So at the moment, I'm going to shut down zone 1 of my Azure virtual machine. To do that, you will see here, it asks you to add an action down here. I'm going to add the fault. And once I go in here, it's going to give me all of the built-in faults that are currently added to this. You can see I can go in here and do network case on AKS. I can go down here to the bottom, which I'm currently going to do now, which is shut down a VM. And once I select that, I'm going to choose an abrupt shutdown for 10 minutes. I'm going to go to target resources. And in here is select the VM that I want to shut down. In this case, I've already got this set up, so I'm just going to ignore that. Again, on the second step, we want to shut down zone 2 and zone 3. So I've done the exact same thing again. On the first branch, and think of branch as another step after this step has been completed. I'm going to shut down zone 2, which will be the second VM. I'm going to shut it down for 10 minutes. And then after that, I'm going to shut down zone 3 as well, to see how my availability or data availability on those resources actually works. So I've already got this set up and running here. And what I'm going to do is I'm going to start this experiment. Now remember that this is actually going to shut down those resources in real life. So this isn't a test scenario. This is going to be working, actually shutting down the resources that I've selected there. So that's something really important to bear in mind. So this is going to run. I'm just going to pause the video for a few minutes and restart when this has been completed. So the experiment has started. Just while that is running in the background, we're going to look at the metrics. So on my load balancer here, I went down to the metrics section, and you can see here I've basically added a metric to look at the data availability and the health probe of my application. You can see everything's running at 100%. There's my 3 VMs, all running at 100%. Everything looks really nice. If we go into, if we go back here, for example, I've ran this previously. You can already see here I've ran this previously, and you can see one of the VMs has basically, when 2 of the VMs, you can see here the availability on those 2 resources is 0. So this is an older run, but if we go to the latest session, we'll leave that there and let that happen in the background. So let's look at on the chaos, or on the experiment that we've run at the moment. It's currently running in the background, and you can see here the steps are actually happening here, and then inside those steps are my branches, so the actual events that I want to run, i.e. shutting down this VM. If we look at it, click into that particular branch, we can see here it's running that target. It hasn't actually successfully done it yet, but you'll see here that the target has actually been executed in the back end. So once this is completed, you should see a successful target showing 1. Now let's head over to our metrics. Well, now you can see here at the moment, so everything was 100%. Everything was online, and as you can see here, when we executed that particular orchestration, you can see the first VM that we had in our branch has went offline, but you can see the other 2 VMs are running at 100%. So that means that availability is actually still running on those other 2 VMs. If we look at the data availability, let me just give this a quick refresh. You can see the availability has dropped to 96. So that's still decent. You know, we're still online with our other 2 VMs, but this is a really brilliant way of seeing how you remain online if there is an outage within, say, one of your zones, or a virtual machine is powered off. So it's something I ask every customer to have part of their toolbox to see how reliable and how redundant they are. Now remember, we've switched off that VM. So if we go to our virtual machines over here, if we go into the virtual machines, our first VM should be powered off, which will suggest that it's running. Yeah, you can see it's stopped. Let's go into the Chaos Studio, and if we click out of this and we refresh it in the back end, click back into it, it's still running. So we put it on for 10 minutes. The duration was 10 minutes. So we should be close to completion here now at the moment. And once we do that, we will have the second step spinning up with the next branch, which will shut down VM2 and spin up VM1 again. So in the earlier conversation at the start of the video, I talked about why you would use this. You want to maybe check to see if, for example, your alerts are triggering correctly. So I have switched off VM1. I have an alert in VM1 to say if VM1 is powered off, please send me an alert so I'm aware of it. If we look on that particular virtual machine and we scroll down to our alerts here, we should have multiple alerts to say that VM has been powered off. And as you can see, they've been triggered 2 minutes ago, letting me know that, okay, your production application's offline. Now it's up to you to put something in place, or if you've already got availability zones configured within inside that region, then this should be fine. But it's giving you basically that knowledge to go and put whatever you think is fit in that particular scenario in place. If we go to our environment again and have a look at this, you can see we started our second branch here. So the second VM in that zone should be shut down. Zone 1 should be back online now. And if this loads first, you can see here, it's still showing running targets. So we'll come back to that in a second. If we look at those VMs availability now, so you can see here, this is where we shut down one of our VMs. and you can see here it has went back online. And in parallel to that, you can see the next VM in the green here has went offline as well. So it's showing those two VMs are offline, but our new one is back online. So if we look at our data availability here, you can see it has went back up and then it has went back down again. So showing us basically that the VM is still down, um, but we're remaining online and our applications are remaining robust. So this is just an idea for you guys to run in your environments to check how redundant your workloads are. Hopefully you find this useful. Thank you very much for your time.